There are many scenarios where you may want to compute summary calculations of your PySystem data. One of the most common calculations are running totals, where you may want to know daily, monthly, or yearly running totals of a PyTag as its input. I'm interested in configuring these calculations for tags where each event indicates either a discrete number of items manufactured, as well as tags that indicate the continuous flow rate of my sellable product. These are known as event-weighted versus time-weighted calculations. This video will discuss the differences between these two, but we'll focus on configuring the daily, monthly, and yearly running totals for the time-weighted case. There's a separate video for configuring event-based scenario. We'll finish up by improving our solution by considering how digital states such as I/O timeout or shutdown events affect our calculations. Let's start by discussing how our incoming data affects time-weighted versus event-weighted calculations. Here I'm showing some example data with values coming in hourly. I would like to take a daily running total that resets at midnight of this data. Our calculation will start at midnight, which I've indicated here, and I've mapped over the events from the list on the left over to our plot on the right. You can see that there are some repeat values like 2 5s that come in or 2 7s that come in a row, or sometimes there's a value of 8, for instance, that comes in at 5 a.m., but there's not another value that comes in until 4 hours later. We're going to start by discussing the time-weighted total of this data, and we're going to calculate it hourly. This makes sense when tag represents a process flow rate, such as gallons per hour. Our total will reset at midnight, and the value at midnight is going to be the total for the entire previous day. As an example calculation, the total at 4 p.m. would be summed up like this, because we're using a step function. I'll discuss that in just a second. However, you can see here that I've multiplied 5 by 2 hours because it's the value of 5 for 2 hours here. And I've multiplied the value of 8 by 4 hours because it's 8 for 4 hours here, even though there is only one value of 8 coming in. It is still at 8 for 4 hours. Essentially, we're taking the integral under the curve to get the time-weighted total. Now, most likely your process data isn't set to be a step function. It probably looks something more like this, where there are straight lines drawn between each of the event values. And we essentially do the same thing, except the integral under the curve is slightly more complicated. We just use a step function for simplicity. In contrast, let's take a look at the event-weighted calculation. We have very similar data over here on the left, and we still want to take a daily running total. We want it to reset at midnight, and again, I've mapped over the data from the left to here on the right. For the event-weighted calculation, we're going to calculate the daily running total as new each event comes in. This makes more sense when each event represents the number of units being produced. And we're going to reset our value at midnight, and the first event that comes in either at midnight or slightly after is actually going to set it back to the low level. So the highest level, or the total for the day, will be the event just before midnight. And this calculation looks much simpler. As you can see here, there are 2 5s in a row because there are 2 5s here, or 2 different events. However, there's only one 8 because we only have one 8 event. The length of time that it's 8 does not actually matter in this case. So we have a total of 90 widgets for this day. To learn how to set up this calculation, please see the linked video for event-weighted totals. The approach we're going to use is to use Asset Framework with Analysis Service. We're going to need to specify the input attribute, which is mapped to the pi tag that we're trying to total. It's mapped as a PyPoint data reference. The syntax that we use in Analysis Service is very similar to performance equations. We need to pick a triggering mechanism, which we've already discussed that we want to use periodic for our time-weighted total. And we're going to need an output tag for saving our calculation history. Now, there are some additional considerations. Analysis Service is very customizable using PE syntax, so this is just one example. You need to consider the amount of underlying data in your summary calculation, or the number of events that you're going to pull for the time period of each calculation, as to not overwhelm the PyData archive. For larger queries, such as yearly running total, it makes sense to trigger less frequently, since it's not as important for us to have this calculation update as frequently, and it queries a much larger amount of time from the PyData archive. There is an alternate approach of using PyPoint data references with value retrieval method, which is discussed in a linked video. Let's go ahead and go into the details of how we're going to set up this calculation. We're going to use the TagTot function, which includes this tag, start time, and end time each time the function is called. And this by definition is a time-weighted total. We'll discuss the consequences of imperfect data, such as digital states like IO timeout or shutdown. This is known as the %good, and having less than 100% good will have an impact on your calculation. We're going to make an enhancement to our first solution by enforcing a minimum %good in the TagTot function. And then we're going to make a second enhancement where we explicitly use a %good function to undo a correction that is inherently made in the TagTot function when a digital state exists. Let's go ahead and get started on our first run of the solution using TagTot. Here we're looking at the production rate for one of our pieces of equipment, and we'd like to set up the daily, monthly, and yearly running totals of our production. Let's set this up using Asset Analytics. Let's go over to the Analysis tab and say Create a new analysis. Let's name our first analysis Daily and Monthly Running Total. The first thing I'd like to do is pull in the production rate variable so we don't have to type it out all the time. I'm going to call my variable PR for production rate. And since it is an attribute, I'm going to use a single quote. And you can see that it automatically brings up production rate for me. And I'm going to use PR for the rest of the expressions so I don't have to write it out every time. Let's go ahead and add a new variable. And this is going to be our daily running total. Type in daily running total. And we'll get started on our first expression. I'm going to use the TagTot function because by definition, that is the time-weighted total. And I had to specify 3 different inputs. The first is the tag or attribute that is going to be the input value for this. That, in our case, is going to be PR, which references the production rate tag. Then we need to reference the start time. And I want a running total from midnight today to the current time. And for that, I'm going to use T for midnight today and star for the current time. So this will provide the total of the PR tag, a time-weighted total, from midnight to now. Now, the analysis service doesn't know the time basis for the PR tag or the production rate, but I know that it's gallons per hour. So in this case, I'm going to have to manually add times 24 to make sure that the calculation works out okay. Next, we need to consider what's going to happen at midnight. At midnight, the value in T and star are going to be the same, and the calculation is actually going to have an error. What we'd actually like at midnight is the total of the value from the previous day. So we need to treat midnight slightly differently. Because of that, let me put in an if-then-else statement. I'm going to hold down Shift to get a few extra lines here. I'm going to say if, and then we're going to need to figure out what our if statement is, then, and else. Under the special circumstance where it is exactly at midnight, I'm going to take a slightly different total. I'm still going to use TagTot, and it's still going to reference the production rate, but instead I'm going to use Y and star. Because we know we're going to set this calculation to run hourly, when the calculation actually runs at midnight, T and star are essentially the same thing. So to get the midnight from the day before, we need to use Y. And again, I'll need to multiply by 24 hours. How do we know when to use this particular part of the calculation? Well, since again we're running hourly, we can check what hour we are of the day. In this case, our if statement would be if it is midnight, so if the hour of the day, or if the hour of the current time is 0, then we're going to do this first calculation. Otherwise, for the other 23 times during the day that this calculation runs, we're going to use this second expression here. And this is our daily running total. Let's go ahead and set up a monthly running total. I'll type in monthly running total. And let me go ahead and copy and paste this section here into our monthly running total, and we'll do some edits. We always need to go back to the first of the month at midnight, and there's a special function for that. It's called BOM, or beginning of month. So we'll use that here. So if we go back to the beginning of month, referencing the current time, to now, and do that total, multiplying by 24 hours, that will give us the time-weighted total from the beginning of the month to now. If it is the first of the month at midnight, we're going to have a problem with this calculation because these reference the same thing. So in that case, we'll need to keep star here, but we'll need to go back 1 month. And our if statement is going to be a little more complex. In this case, we only need to use this special function here when it's both midnight and it's the first day of the month. And there we have a solution for our daily running total and our monthly running total for our production rate tag. Let's go ahead and hit evaluate and see if we have some values, which we do. Now, we're currently scheduled as event triggered, and we were planning on using periodic, where we run the calculation every hour. So let me change this to periodic, and I'll configure this to run once per hour. And I also need to map my outputs to tags. Our daily running total, we want to write to a tag every time it calculates. And I'm going to create a new attribute. I'm going to call this attribute daily running total. And I'm going to call this monthly total, monthly running total. Now I could put my yearly running total in this same analysis as well, but I'm actually going to put it in a separate one because I'm going to use a different scheduling. I'll still run it periodic, but probably only run it once per day since it could be an expensive calculation on the PyData archive, so I don't want to be running it every hour. Let me go ahead and check in my changes. Let's wait a few seconds and the calculation should start on its own. We can go ahead and see here that it's running. If I go back to my Attributes tab, I can now see point created for my 2 new calculations. Let's go ahead and backfill these results and see if they make sense. Let me do backfill recalculate, and the date right now is the 2nd of March, so let me go back and make sure I get at least through the 1st of this year. So we'll do star minus 90 days. And I'm going to permanently delete any existing data in these 2 output tags and recalculate. Wait for the green check mark that it's completed. Let me go back to attributes, hit refresh. You can see we have some data. Let's go ahead and take a look at our underlying data. For instance, here we have production rate. I can go ahead and right click and go to trend. And here we have the last 10 days. You can see in general, we are going between a value of 5 and 8. We go ahead and take a look at our daily running total. We right click and go to trend. And you can see here the last 10 days of the running totals. Let's go ahead and look at the actual data that's in the archive. So let's go to time series data. Let me go back 10 days again. Let's see if we actually get the maximum at midnight. And I have to go a little bit further back. You can see here we have a value of 163 at midnight from yesterday. So that would have been our maximum, or daily running total. Now you can see there are some data points missing. It's probably because we have compression turned on. So there was probably a value of 6 that came in multiple times. Let me go ahead and take a look at if compression was turned on by default for this output tag. I can actually right click, or I can actually open this, check the PyPoint data reference. We can check it right in here and check if compression was turned on. And sure enough, compression is turned on. So if you needed every output of your calculation for sure, make sure to turn off all exception and compression on your output tags. Let's take a look at the monthly running total, the trend. And you can see here, let's go actually back to January 1st. And you can see here that it resets at February 1st and again at March 1st, which was just a few days ago. And let me go ahead and look at the underlying data. Let's make sure we have a maximum at the end of the month. Goes back 65 days or so. Oops. And let's check the end of January. And sure enough, right at midnight on February 1st is the maximum for the entire month of January, which is what we wanted. So that's why we set up that if then else statement. All right, let's go ahead and now configure our yearly running total. And we're going to make a new analysis for this one because we're going to use a slightly different schedule for this one. Let's type in yearly running total. And let's bring in our variable production rate as PR, just to make it easier to work with. Okay, let's add a new variable, and this is going to be our yearly running total. And I already know that there's going to be some complexity with if-then-else statements because there's going to be a special situation at January 1st of each year at midnight. So let me just get some of that in here. Then else. And the easiest scenario is the else statement. So let me start with that. So that's TagTot, and it's going to be a time-weighted total of the production rate. And we need to go back to January 1st of the current year each time we run this calculation. And the easiest way to do that is to go back to January of the current year, whatever day of the year, of the month it is, and then we'll go back to the beginning of January. So we use this trick of combining BOM for beginning of month and January. And then let's go ahead and use star. And then that would be the time range over which we're taking the total. The special scenario is when it is January 1st at midnight, and we need to do a slightly different calculation. In that case, we need to just go back 1 year from, if it is January 1st at midnight now, we need to go to last year's. So that's going to be star minus 1y. And then we're going to go back 1 year. And the if statement is if it is currently midnight, and it is the first day of the month, and it's January, you use this first TagTot that we have here. Otherwise, during the rest of the time that you're calculating during the year, as this calculation runs, you instead use this one. And again, this particular scenario only works here because we're going to be running in a certain type of scheduling. And in fact, let's do periodic, and let's do it once per day. So let's just run it daily at midnight each day. So technically, since it's only running at midnight, we could have left this first part out, but I have it in there for completeness because in case the triggering ever does change slightly, if someone does set this to run hourly, it would still work correctly. All right, let's map this output. So our attributes here were daily running total, monthly running total. Let's map this to yearly running total. And I hit evaluate to see if the calculation works. And it does look good. So let me go ahead and check it in. And let me backfill it, and let's see what it looks like from January 1st until now. And you can see here, it looks like there are maybe about 60 data points here because it's been that many days. The calculation runs once per day, and it's a running total for the year. And each time it does this calculation, it's actually going back to January 1st and pulling all of the data and running a full calculation each time it calculates. Let's go ahead and take a look at some of the next steps or some of the enhancements that we were going to discuss for our data. All of us have imperfect data, and we often have digital states such as IO timeout or shutdowns that show up on our data. And we want to at least be able to understand, if not correct for those imperfections in our data. Here, as you can see, I have an example of an IO timeout showing up in my data at 5 o'clock, and it has an IO timeout for 2 hours from 5 p.m. to 7 p.m. Now, without the IO timeout, if there were no data during that time period and we were using a step function, such as the graph showing in the lower left, we would, with a time-weighted calculation, we would assume that the value of 7 remained at 5 and 6 o'clock, and we would have ended up with a total time-weighted value of 121 at 7 p.m. Now, you might think that by the IO timeout coming in at 5 o'clock, that the timestamps for 5 o'clock and 6 o'clock are wiped out, and you would get 121 minus 14, or a value of 107. But that's not actually how TagTot works. Instead, it runs a calculation and determines the percent good at 7 p.m. So out of the 19 hours of our TagTot calculation, from midnight until 7 p.m., 17 of those hours, or 89.45% of the time, we have good data. So what TagTot does is it takes the value of 107 that we expected and divides by 0.8947 to make some sort of assumption that there was supposed to be some data during that time period. The final calculation results in a value of 119.6. Now, what does that look like for when you don't have a step function? The actual calculation is the same, and we do a correction for percent good. However, from the time period from the last good event until the IO timeout, there's actually a straight line. So our calculation is assuming that the value of 7 continued from 11 a.m. until 12 p.m. when the IO timeout occurred. After 12 p.m. when the IO timeout occurred, you'll start having some corrections for percent good. How can we correct for some of this? Our first enhancement is to enforce a minimum percent good in the TagTot function. We can force TagTotal to provide only a result when there is at least a minimum percent good. A second correction that we can make is to actually undo the percent good division by using the percent good function, and we'll discuss that as well. First, let's enforce a minimum percent good in the TagTot function. However, you need to be aware that this could result in failed calculations if you fall below the percent good. To do that, all you need to do is go ahead and click on one of your TagTot functions, for instance, right here. And as you can see, there are a variety of different options. The first option is to just use the attribute name, the start time, and the end time. However, the third option here is to put in number percent good. So we can add a fourth attribute here, and for instance, put in the value of 90. And I can do this on all of them. And if at any point our calculation falls below 90% good, instead of getting a result, we'll get a calculation failed. Now in this case, it still is doing the correction for percent good. We would also do this for our yearly running total. A second option is to actually use the percent good function if you don't want it to do the division or the correction for the percent good that we discussed. The way to do that is to multiply by the percent good to undo the division that we did. And we'll take a look at that now. If I go here, I can multiply by the percent good function, which is PctGood. And I actually need to feed in the exact same attributes that I used before, except for obviously the percent good portion. So I need this section right here. And I'm going to want to be able to make sure to pair these up exactly. And this has a value between 0 and 100, so I'm going to need to divide by 100. Okay. And let's do the same thing for the yearly total. In this video, we've discussed the difference between time-weighted versus event-weighted totals and the use of TagTot for time-weighted totals. We've discussed the consequences of imperfect data, such as IO timeout or shutdown events, and how to enforce a minimum %good. We've also used %good function to undo the correction that's made when digital states exist in our data. And we came up with a periodic hourly, daily, and monthly running total shown here, as well as a periodic daily, yearly running total.